Hi everyone, and welcome back to another video of IGCSE Math Preparation Series. My name is Erfan, and I'm back with a bunch of past year paper questions, topicalized past year paper questions. The topics that we're going to look into are geometrical vocabulary and similarity. So if you haven't watched the previous two videos, I suggest you to go ahead and watch them and come back again here and try to answer these questions yourself. So without any further ado, let's take a look at question number 1. Give the correct mathematical name for the shapes described below. So what do we have here? 3 descriptions. So I'm a quadrilateral, all right? I have 2 pairs of parallel sides, but no right angles. That narrows it down to a parallelogram, right? That's because we have 2 pairs of parallel side. What else has 2 pairs of parallel sides? What I can think of is, because it says no right angle, so square and rectangle is not correct. Then how about rhombus, right? Rhombus seems it matches this description. And for the parallelogram, we actually have no line of symmetry, 0 line of symmetry, right? If you still recall what line of symmetry was. But for a rhombus, we have 2, right? So basically, the line of symmetry means when you fold this shape along this line of symmetry, it must basically superimpose perfectly. In other words, these 2 portions, they are mirror with each other, right? So the answer is rhombus. The next one, I'm a quadrilateral. I have 1 pair of opposite angles that are equal. I have 1 line of symmetry. So 1 pair of opposite angles that are equal. A kite has 1 line of symmetry, but does it have 1 pair of opposite angles that are equal? Well, yes, these 2, right? This is 1 pair, and these 2 are not equal, all right? So that's it. The answer is kite. Moving on to question number 2. The quadrilateral has rotational symmetry of order 2 and no lines of symmetry. Write down the mathematical name of this quadrilateral. What I can think of right now, the only quadrilateral which doesn't have any line of symmetry is parallelogram, and the number of rotational symmetry, it is 2. Basically, rotational symmetry means when you rotate this around its center and you make 1 complete revolution, so how many times it's gonna fit its outlines perfectly. So if you rotate this parallelogram 180 degree, so you're gonna get the same shape, right? If you rotate it 90 degree, this is what you get. And if you rotate it 90 degree more, again, you get the same shape, right? So that is 1 time. And if you rotate it 180 degree more, which is 360, then that is 2 rotational symmetry, right? The order is 2. So that's it. The answer is a parallelogram. Moving on to question number 3. Okay, we are given a bunch of triangles. Write down the letters of all triangles which are congruent to the shaded triangle. So congruency means they both must be identical. This is our triangle that we have to refer to. So this side has 4 squares, this side has 2 squares. So what other triangles have the same description? That is G, right? 2 and 4, and E, 2 and 4. So the answer is basically E and G, right? That's the answer to A. In part B, most probably they're asking for similarity, right? Similar but not congruent to the shaded triangle. So that means we shouldn't mention G and E again, because G and E, they are congruent and similar, right? Now, similarity means there must be a ratio between the corresponding sides, a constant ratio. So meaning which that's the case of enlargement. If this is 4 and 2, look at A. This is 2 and this is 1. So if you divide each side by 2, you get 2 and 1 respectively. So A is similar and the scale factor is half in this case. We're multiplying it by half. What else? F is not, because this is 3, right? You're multiplying 2 by 1.5. That gives us 3. But if you multiply 4 by 1.5, that should give us 6, not 5. So F is not correct. How about C? This is 3. This is 7. No, it should be 6. So that idea is rejected. How about B? Well, B seems it's similar because this is 4 and this is 8. So if you multiply everything by 2, you get B. The scale factor for B is 2. So the answer is basically A and B. Moving on to question number 4. Guys, for each question, I strongly suggest you to pause the video and answer it yourself. Then you can check your answer with me. Okay, these two triangles are congruent. Write down the value of x. If they're congruent, that means they're exactly identical. So the corresponding angles and corresponding sides are basically equal, right? That's the idea. So if this is 9.65, the angle opposite to that is 74. So look for the same side on the second triangle, 9.65. What is the angle opposite to that? That is x. So x should be equal to 74, right? We do the same thing for y. Well, y is this side opposite to this angle. And what is that angle on the first triangle? That should be, if this is 46 and 74, 60 is left out, right? That's 60. So the side opposite to 60 on the first triangle is 8.69. That should give you the value for y. Okay, so it's just comparing these two triangles. One of them is tilted sideways, that's all, but they're congruent, so it doesn't change anything. Moving on to question number 5. We have the word trigonometry. We haven't reached that chapter yet. So from the above word, write down the letters which have exactly 2 lines of symmetry. You know what line of symmetry is. For example, T, the letter T, maybe I can maximize T for you so you can see it better. We have only 1 line of symmetry, right? This is not a line of symmetry. This is not a line of symmetry, right? This is not a line of symmetry. So it's just 1. We're looking for exactly 2. Why they say exactly 2? Because if you look at O is basically a circle. And circle has infinitely many line of symmetry. This is a question that I ask the students all the time, and many of them, they don't know the correct answer. They come up with 1, 2, 3, 4, but basically any line that passed through the center is a line of symmetry for a circle. So we have infinitely many, right? Now, that's why they use the word exact here. So R doesn't have any, so this is 0. Maybe I can write on top of each letter. So T is 1, R is 0, G is 0, O is infinity, N is 0 as well, O is infinitely many, M is only 1, right, passing through the center, this one, and E is 1 again, passing through the second horizontal line. That's the line of symmetry. T is 1, R is 0, Y is 1. So I, if I maximize I for you, you can actually draw two lines of symmetry for I. One is horizontal and one is vertical. So the answer is I. For B, rotational symmetry of 2. So if you rotate it, it basically fits its outlines 2 times, not more, not less. Now for T is 1, for R is 1, for I is 2. Yes, I is 2. How about N? Well, N is a little bit tricky. If you rotate it 90 degree, you get Z. And if you rotate it 90 degree again, what does that give us? You get N again. So rotational symmetry of order 2 is basically N, because this is after 180 degree, you get N itself. Again, after 180 degree, you get N again. So moving on to question number 6, look at this diagram, write down the order of rotational symmetry. Okay, how many times you have to rotate this? You rotate 45 degree. So white goes here, black goes here, but that doesn't fit the original outline. So I have to rotate it 120 degree, again 120 degree, and again 120 degree. So that's 3 times. So the order is 3, right? As you rotate it 360 degree along that path, it matches its own outfits 3 times, right? And I gave you the degree already. There are the lines of symmetry on the diagram. Okay, it should be more than 1 for sure. This is 1 passing through the center. Let me move that slightly. Okay, this is 1. And if you fold it, this side is basically mirrored with this side. And there is another one here. So ignore the first one. These two parts, basically these two halves are mirrored as well. And there is one more, the third one, which is here. So that's it. Okay, we're done. Moving on to question number 8. Okay, I believe this is the last question for symmetry. Then we go to similarity. All right. This is an interesting question. They said you shade one square, and as a result of that, this diagram or this shape will have one line of symmetry, only one line. I want this part to be mirrored with this part, so it's obvious what I need to do. I have to shade this square, and the line of symmetry is basically this line now. Okay, they didn't ask us to draw the line of symmetry, so if you don't draw this, it's fine, but you have to definitely shade this square. The next part, rotational symmetry of order 2. So this is the center, and if you start rotating this rectangle around its center, we want to match the outfit or the original shape 2 times as we rotate it 360 degree or 1 complete revolution. So I think it's quite obvious which square I have to shade. It's here, right? So if you rotate it 180 degree, this thing goes here, right? And this thing goes here, and then another 180 degrees. So the order is 2 basically. Moving on to question number 9. We have triangle ABC, which is similar to triangle PQR. So they say find PQ. Okay, similarity means there is a constant ratio between the corresponding sides. PR over, so these two are corresponding sides. PR over AC is equal to QR over BC, and this is also equal to QP over AB. Okay, you should know that. That's what similarity means. However, we don't need all these values. So I know 21.7 over 12.4, and then PQ is here. You have to divide it by the corresponding side from the other triangle, which is 5.2. So you have to write this. I just wrote this to do a quick recap about similarity. And you make PQ the subject of the equation, and the answer is 21.7 times 5.2 divided by 12.4, 9.1 cm, right? Okay, that was an easy question. Question number 10, just be patient. It's gonna get harder, I promise you. In the diagram, triangles ABE and ACD are similar. So the bigger triangle and the smaller triangle. Can you see that? This is the smaller one, and this is the bigger one. So you don't need to prove why. However, maybe it's worth to tell you guys why. According to AAA, basically, they both share this angle together. And these angles, basically this and this, are equal, because if you have a pair of parallel lines and a line is cutting them, so we have corresponding angles. The C and B, they are corresponding angles, so therefore they should be equal. Same thing here, D and E, corresponding angles, and we have two similar triangles according to AAA. Now we have to find P and Q. So again, you don't need to prove why they are similar. They didn't ask such thing. However, if they are similar, there must be a constant ratio between the corresponding sides, meaning which from the smaller one, let me write the value for the smaller one. This is 5, this is 4, this is 8. You shouldn't exactly follow my footsteps here. I'm just doing this to make it more clear for you guys. So the bigger side of the bigger triangle is Q plus 8, okay? And then this side is 4 plus 5, which is 9, and this is P. So if you want to find P, for example, you have to find the corresponding side on the small triangle, which is 4. So P over 4 must be equal to, don't use this side because this is an unknown, so we end up having two unknowns. However, make use of these two sides, 9 and 5. So put it equal to 9 over 5. Therefore, P is equal to 9 over 5 times 4, which is 36 over 5. That is 7.2, I believe, right? And that is cm. So that takes care of P. For Q, we do the same thing from the bigger triangle, Q plus 8 over the corresponding side is 8 from the smaller triangle is equal to, you can use again 9 over 5, or now that we have P, you can use 7.2 over 4. It doesn't matter. It's the same ratio. So I have to cross multiply. So I get 5Q plus 40 is equal to 72. So 5Q is equal to 32. Therefore, Q is equal to 6.4 cm, right? 6.4 cm and 7.2 cm. Moving on to part B. Oh, that's another question. Spherical balloon. So let me erase everything. We don't need those information. Two containers, looks like a vase, and mathematically similar in shape. The larger container has a volume of 3,456 cubic centimeters. Surface area is this. The smaller container has, so basically they are similar, right? And we are provided, we're not given the height, right? Nor the radius of the base, because that helps us to find K. However, we have other informations given to us which helps us to find K. If you recall, KQ is volume, the ratio of the volumes, right? So I used the bigger one over a smaller one, and the bigger one is this, the smaller one is this. So that helps me to find K. 3,456 divided by 1,458 should be k cubed. Therefore, k is the cube root of that fraction. Let me see. So the cube root of that is 1.3. Okay, 1.33. And now what I'm gonna do, I have the value for k. I compared the surface areas, right? So they want the smaller one. So remember, the k that I found, I put the bigger one over the smaller one. So I have to actually follow the same pattern when I want to find out the surface area, meaning which the surface area of the bigger vase, which is 1,224 over the surface area of smaller container, let's call it x, this is equal to k squared, right? Because area over area is k squared, not k cubed. Okay, so be careful which one you put on top. So maybe another student put VS over VL in this case. When you come to the surface area, you should put the value of the smaller vase on the bigger vase. So just make sure you obey that order. Now, X is 1,024 over K squared. And the answer is 576. And that's an exact answer. So don't round this up, guys. You can use the answer in your calculator with the repetition of 3. So if you keep it that way, you get the same exact answer like me. And don't forget the unit, we're talking about area, so it should be squares centimeter. That takes care of question number 11. Moving on to question number 12, we have two triangles and we're asked to find the lengths BC, this horizontal length. What other information is given? We know the area of APQ, the bigger one, right? That is 99, and the area of the smaller one, which is ABC, this one, is 11. So let's divide them. That gives us K squared, not K, because we're talking about areas. And the answer is 9 is equal to K squared, therefore K is 3. Now that we know K, we can find the length. This is a 2D, so there is no volume. It should be length. Now, PQ, this is 12. How much is this one? So remember, we divided the bigger one over the smaller one. So I do the same thing here. 12 over X, if this is X, BC, this should be equal to K, not K squared. And K is 3. So X is 12 divided by 3, right? K goes down, X goes up. So you're left with 12 over 3, and the final answer is 4 cm. So again, I repeat, because this is very important, it doesn't matter which way you arrange this fraction, right? At the end, you should get the same answer. Maybe quickly, I do that right here. Let's say student B divides 11 by 99 and put that equal to K squared. Therefore, the K that he gets is 1 over 3. And then you want to compare these sides together. He must says the smaller one, which is X, over the bigger one, which is 12. This should be 1 over 3, right? And X is therefore 12 over 3 or 4. As you can see, we get the same answer. It doesn't matter. Just whatever you put in the numerator, keep doing that till the end when you want to find out the area, volume, or the length. This is the last one. We have two cars. One is the real one and one is a model. So the volume of the bigger one and the smaller one is given, and the length of the real car is given as well. So they're asking us to find the length of the model car, which is very tiny. like a toy car. So again, that would be wrong if you solve this using ratios or unitary method. That is absolutely wrong. I'm going to find k cubed, right? The scale factor cubed by dividing these two numbers together. This time I'm going to use the smaller one on top over 65. This is my k cube. And then if the length of the smaller car is x and the length of the real car or the bigger car is 4.4, this should be equal to k. Right here, you get the value for k, and then you go substitute it in the second equation that we formed here. So what is the value of k? 0.05 divided by 65. And then you take the cube root of that using your calculator. So the number that you get on the screen of your calculator, don't round it up. Don't do anything to it. Just take the cube root of the answer, and that gives me 0.092. So this is rounded to 2 significant figure. Maybe I better go to 3 significant figure, which is 0.196. Yeah. So now I know the value of k. X can be found easily. The answer is 0.4 meter, actually 403 meters. So that's it. We can stop here. I hope you have enjoyed the video. Don't forget to like and subscribe, and I'm gonna see you in the future videos. Stay safe.